March 4th, 1944. American bombers are headed for Berlin, and this time, their little friends don't turn back at the border. For months, the math was brutal. In late '43, the worst raids lost about 1 in 5 heavy bombers. Crews called for escorts and watched them peel away at the German frontier, low on fuel. Fuel's good now, but it won't be if we have to fight over Berlin. So why is today different? Same sky, same flak, same wolves waiting. What changed is the airplane and the thinking behind it. An immigrant engineer in California bet his job on a wing most people said wouldn't work in combat, and a British engine that refused to run out of breath at 30,000 feet. Debin control, red leader. Little friends are staying with the big boys today. To Berlin and back wasn't a slogan. It was a promise built from numbers, metal, and nerve. Let's see how they finally kept it. He was born in Hornbach, Germany, December 30th, 1899. His father was Austrian, which made him Austrian by law, but German by heart. When he saw a flying machine for the first time, something in him changed. While other children chased kites, he chased the idea of flight itself. He taught himself mechanics, drawing, engines, anything that could bring him closer to the sky. By World War I, he wasn't a pilot, but a mechanic in the Austro-Hungarian Air Corps, learning the anatomy of flight from the inside out. After the war, Europe was broken, factories silent, jobs gone. In 1925, Schmued left everything, language, home, identity, and boarded a ship to Brazil. He had no money, only his sketches and ambition. In Brazil, he joined General Aviation, a division of General Motors designing parts no one had asked for, and improving engines that already worked. It was the beginning of a pattern: do more than expected, make it better than before. By 1931, General Motors noticed. Immigration quotas then were harsh, less than 800 technical visas for Europeans that year, yet Schmued got one of them. He was sent to America. He joined Fokker Aircraft Corporation of America, a GM subsidiary in New Jersey. There he learned American engineering fast, practical, and industrial. When North American moved west to California, Schmued followed, but the trip cost him dearly. His wife, Louisa, was killed in a car crash on the way. He survived barely and carried the scar the rest of his life. After months of recovery, he walked back into the hangar, slower, older, but more determined than ever. James H. Dutch Kindleberger, North America's president, saw something rare in him, a man who'd lost everything, yet still built. Schmued started on bombers like the NA-62, later known as the B-25 Mitchell, and trainers like the NA-35. But his heart was already sketching something faster, smaller, and far more dangerous. I'm not here to build yesterday's airplane. Give me 120 days. The Brits want P-42s. Are we taking the safe road or building the right one? It was 1940. The British wanted licensed P-40 Warhawks. North American offered something else, a brand new fighter designed from scratch in 4 months. If it failed, the company would pay the price. But if it worked, it would rewrite the rules of range, speed, and survival, and make a German immigrant the father of an American legend. Name: Edgar O. Schmued, not Schmued, divided by Schmued. Title: Chief of Preliminary Design, North American Aviation. City: Inglewood, California, not Inglewood. In the spring of 1940, representatives from the British Purchasing Commission arrived in California with a simple proposal. Britain was losing aircraft faster than factories could replace them. They wanted North American to build P-40 Warhawks under license fast, safe, proven. James Dutch Kindleberger, president of North American, could have taken the easy deal. But his chief designer, Edgar Schmued, leaned forward and said something that changed aviation history. We can design you a better fighter from scratch in 120 days. The British thought he was insane. His own team thought he was insane. But desperation breeds trust. On May 29, 1940, the contract was signed: 320 aircraft, 4 months to first flight. No prototype, no margin for error. Schmued assembled 150 engineers and draftsmen, working around the clock in rotating 12-hour shifts. They slept on drafting paper, ate next to blueprints, and built an airplane faster than anyone thought possible. His secret weapon wasn't caffeine. It was data fresh from the National Advisory Committee for Aeronautics, or NACA. At Langley, a quiet engineer named Eastman Jacobs had spent years testing a new kind of airfoil that promised to cut drag by almost 40%. Move the thickness back, keep the boundary layer calm. Most wings were thick near the front, creating turbulence and drag. Jacobs' design pushed that bulge almost halfway down the wing, smoothing the airflow and buying speed without burning more fuel. Schmued saw more than a laboratory curiosity. He saw a way to cheat physics. To make laminar flow work, every surface had to be flawless. Rivet heads sat flush with the skin. Wings were wet sanded and painted again and again until they reflected like glass. Quality inspectors rejected panels other companies would call perfect. They weren't just building airplanes, they were building precision instruments by hand. Day and night, the NA-73X took shape. 4 months after signing, the impossible machine stood ready. Smooth skin, narrow fuselage, a cockpit shaped by wind tunnel math, not aesthetics. October 26, 1940. Mines Field, California, now known as LAX. Test pilot Vance Breese climbed into the prototype, pushed the throttle forward, and made history. It handles like a sports car. The prototype leapt from the runway with a grace nobody expected. It climbed clean, rolled smooth, and turned like it wanted to fly forever. Within days, the British had a name for it, Mustang. In just 120 days, a German-born engineer and a small American factory built something the world hadn't seen before. A fighter designed by mathematics, refined by human hands, and born from sheer audacity. But the Mustang story was only beginning. Below 15,000 feet, it was a masterpiece. Above 15,000, it was a disappointment waiting to happen. And for all its beauty, that single flaw would nearly kill the project until a British test pilot read its potential between the clouds. At sea level, the Allison engine was fine, strong, reliable. 1,000 horsepower of American muscle. But as the Mustang climbed, the numbers began to fall. 15,000 feet, 16, 17, and the power curve dropped like a stone. Over Europe, the Luftwaffe fought at 25 to 30,000 feet. The air was thinner, the fights quicker, and the Mustang powered by the Allison V1710 couldn't breathe up there. Feels like she's dragging a parachute. She just stops climbing. It wasn't the airframe's fault. Schmued's design was brilliant. The wing was clean, the drag low, the range unmatched. The problem sat right behind the propeller, the Allison supercharger. Allison's supercharger was single stage, single speed. Think of it like lungs that only breathe comfortably at sea level. As altitude increased, air pressure dropped, and so did horsepower. The engine still made about 1,150 horsepower on takeoff, not 150, as some myths claim, but its boost system couldn't maintain that power in thin air. And that was deadly math. The bombers B-17 seconds and B-24 seconds flew at 25,000 feet to stay above flak. The P-51 Amperes could protect them for only part of the way, then had to turn back before the German border. Once the escorts left, the wolves came. Where are the little friends? Gone. Out of gas, out of altitude, out of reach. The airframe can go farther, the engine can't. North American engineers tried every tweak they could. Smaller props, new carburetors, cleaner inlets, but physics doesn't bargain. Above 15,000 feet, the Allison gasped. Across the ocean, British pilots loved the Mustang's agility down low, but they called it a sprinter, not a marathon runner. She's perfect for a run under the clouds, but up there with the Jerrys, she just can't keep up. That ceiling 15,000 feet became a wall. Beyond it, American bombers were alone. The air over Germany belonged to the Luftwaffe. But every flaw invites a fix. In April 1942, a British test pilot named Ronald Harker flew a Mustang and wrote a note that would change everything. Extraordinary airframe, wrong engine at altitude. The message was short, but its echo would cross the Atlantic and give the Mustang the lungs it needed to fly to Berlin and back. In April 1942, a Rolls-Royce test pilot named Ronald Harker climbed into a Mustang Mackay for a routine evaluation. What he found was anything but routine. Extraordinary airframe, wrong engine at altitude. Harker realized what no one on either side of the Atlantic had acted on. The Mustang's airframe was a masterpiece, fast, efficient, balanced, but it was suffocating above 15,000 feet. He sent a telegram straight to Rolls-Royce headquarters in Derby. 5 words that would change the air war. Flight testing Mustang needs Merlin engine. Rolls-Royce didn't wait for Washington's permission. They pulled a Mustang from RAF service and, at their Hucknall facility, fitted it with their newest engine, the Merlin 61. The Merlin's two-stage, two-speed supercharger was a mechanical symphony, compressing thin air twice, cooling it between stages, and feeding the cylinders dense oxygen all the way to 30,000 feet. It produced 1,500 horsepower, where the Allison was gasping for 9 to 100, same airframe, different heart. Shepard advanced the throttle, and the Mustang surged forward, lifting into the autumn haze. 25, 30,000, still pulling. At 30,000 feet, the engine was still climbing hard. The airframe felt alive again. When Shepard dove and leveled out, the airspeed needle touched 433 miles per hour faster than anything with a propeller had any right to be. The British called it the Mustang X. They knew it wasn't just a test flight, it was proof. The right engine had finally met the right wing. Across the ocean, the Americans were listening. The Army Air Forces got the test data, a 50-mile-per-hour speed gain, a 10,000-foot jump in service ceiling, and immediately approved a license-built version of the Merlin for U.S. production. In Detroit, Packard Motor Company began producing the Merlin under license.
In the heart of
they
Detroit,
called it the Packard Merlin
the Packard Motor Company factory
1650,
hums
a hand-built
with
British
activity.
design, re-engineered for American mass production. British precision, American scale. Factories in Detroit, Dallas, and Inglewood, linked by trains, telegraphs, and one impossible deadline. By November 30th, 1942, the first American-built Merlin Mustang, designated XP-51B, rolled onto the runway at Inglewood, climbs like a homesick angel. In a single leap, the Mustang's ceiling jumped from 31,000 feet to 42,000. Top speed rose to 440 miles per hour. More importantly, it could hold that speed for hours. The Mustang's transformation was complete. What had begun as an underdog experiment in a California workshop was now the long-range escort the Allies had been praying for. From Derby to Detroit, from British blueprints to American steel, a chain of factories turned a brilliant idea into a strategic weapon. The result was more than a new fighter, it was a partnership. British engine, American fuel, immigrant designer, and a factory network that could scale. In less than 3 years, the Allies had turned an experiment into an air superiority machine. The Merlin didn't just fix the Mustang, it unleashed it. And soon, those engines would be heard over a city no Allied fighter had ever reached before, Berlin. The Merlin gave the Mustang its lungs. But what truly made it a long-range killer wasn't the engine alone, it was the airframe itself. Every inch of that design fought drag in ways no other fighter of the war could. North American's engineers, led by Edgar Schmued, built on research from NACA's Eastman Jacobs, the 45-100 airfoil. By moving the thickest point of the wing almost halfway back from the leading edge, they created a pressure pattern that delayed turbulence and reduced drag by as much as 40%. We fought drag where it hides rivets, joints, ducts. Unlike most factories, North American insisted on perfection. Rivets sat flush, panel edges were aligned within 0.05 of an inch. Each wing was sanded, primed, and sanded again until the surface gleamed like glass. True laminar needs near-perfect surface. War conditions rarely allow it. The manufacturing discipline still cut drag and extended range. Was it true laminar flow in combat? Not perfectly. Dirt, flak holes, even bug splatter could disrupt it. But the discipline behind the process gave the Mustang something no other. Fighter had a cleaner, faster cruise. The magic didn't stop at the wings. Beneath the belly sat one of Schmued's most clever tricks, a radiator duct that turned drag into thrust. Called the Meredith effect, it used heated air from the radiator to generate a small jet-like push at high speeds. Not enough to replace the engine, but enough to offset much of the cooling drag. At 400 miles per hour, every ounce of thrust counted. Fuel made range, and range made victory. Schmued's team redesigned the Mustang's internal layout to carry an extra 85 gallons behind the pilot, a risky but ingenious choice. With that aft tank full, the center of gravity shifted dangerously aft. The airplane became twitchy in pitch, the nose wandered, and a hard pull could flip it. Pilots were trained to burn that tank first, then jettison their external tanks before engaging. Burn the fuselage tank first. Drop the tins before you mix it. Those tanks, 75 or 108 gallons each, turned a short-range interceptor into a continent-spanning escort. Combined with the Mustang's efficiency, they gave a combat radius of nearly 750 miles. For the first time, American fighters could stay with bombers all the way to Berlin and back. Imagine the math. Debden Airfield, Essex, 580 miles to Berlin and back. Each drop tank gave another 100 miles. Each gallon saved by cleaner aerodynamics was a bomber crew brought home alive. The P-51 didn't conquer the skies with brute force. It did it with balance between power and precision, strength and subtlety. We didn't make a miracle wing. We made an honest one, and we built it right. Laminar-flow wasn't magic. The discipline behind it was. Every rivet filed, every duct shaped, every inch of aluminum mattered. The result wasn't just range, it was reliability. The kind of reliability that let pilots trust the math more than luck. With clean wings, a breathing radiator, and the fuel to cross half a continent, the Mustang became more than a fighter. It became a bridge between the factories of California, the refineries of Texas, and the bomber crews fighting over Europe. And soon, that bridge would carry them into the heart of the Reich, where the Luftwaffe still ruled the sky. At least, they thought they did. March 4th, 1944, Essex, England. The 4th Fighter Group readied for a mission no Allied fighter had ever attempted to escort the bombers all the way to Berlin and bring them home. Form up tight. Burn the fuselage tank first. Drop the tins before you mix it. Lieutenant Colonel Don Blakesley led the mission, a veteran of the RAF before joining the U.S. 8th Air Force. He understood both the enemy and the sky they were flying into. Each Mustang carried twin 108-gallon drop tanks and an 85-gallon fuselage tank. The plan was simple: burn the rear tank first, then jettison the drops before combat. Every gallon had been calculated. Every mistake could mean a swim in the North Sea. Red leader to all flights: we're crossing the coast. Check fuel. Stay high. Expect flak over Brunswick. Below them, 316 B-17 bombers droned eastward, slow, heavy, and vulnerable. Until now, their escorts had always turned back halfway. Today, the little friends were staying. They climbed to 27,000 feet, throttled back to cruise power. The Merlin engines purred at altitude where the Allison would have choked. For the first time, American fighters and bombers crossed into German airspace together. Near Brunswick, black flak erupted through the clouds, and with it, the first Messerschmitts, Bf 109 seconds and Fue 190 seconds, dove in from above, expecting the sky to be empty of fighters. But this time, the Mustangs were still there. 2 down in 3 minutes, Merlin still singing. Captain Don Gentile, Blakesley's protege, scored 2 kills in the first 3 minutes, a Bf 109 and an FW 190. The Mustang's high-altitude performance and speed let him dictate the fight. He climbed, turned, dove, always with energy to spare. The Mustang could dive safely at over 500 miles per hour, faster than the German fighters dared. And when it came to climb, the Merlin's 2-stage supercharger gave the edge above 25,000 feet. That extra 100 feet per minute meant control. Whoever could climb higher could choose when to attack or when to leave. The secret wasn't turn rate, it was energy. The Mustang's laminar wing let it sustain high-speed turns without bleeding momentum. German pilots found themselves trapped slower in a dive, unable to outclimb, outturn, or outrun. They came from above, out of the Sunday. You'd roll to evade, and they were still there behind you, always higher. For years, the Luftwaffe owned that sky. Now, in a single mission, they realized the advantage was gone. The Mustang didn't replace its allies, it completed them. It was the first to balance speed, altitude, and endurance in one frame. The price of that balance was fragility. A single rifle bullet through the radiator could end a mission in minutes. Coolant leak, pressure dropping, many Mustang pilots never made it home. But they gave the bombers something numbers alone couldn't measure: confidence. Before the P-51, bomber crews faced 20% loss rates on deep raids. 1 in 5 didn't return. By early 1944, those numbers began to fall 3%, then 2, then less than 1. It wasn't because German flak got weaker, it was because the Luftwaffe had to fight through Mustangs first. Every bomber that made it home was a testament to an immigrant's design and a partnership's resolve. By the time the bombers reached Berlin, the weather had turned. Clouds covered the city, anti-aircraft gunners fired blind. Yet the B-17 seconds dropped through radar, and the escorts stayed overhead, chasing the interceptors that dared rise. At 12:15, American fighters circled above the Reich's capital. Below them, black smoke from flak mixed with the cloud deck. The Luftwaffe was still fighting, but something deeper had broken. When I saw Mustangs over Berlin, I knew the jig was up. The myth of Fortress Germany died at 27,000 feet. The air war turned almost overnight. With the P-51, the 8th Air Force could strike anywhere, anytime. The Germans couldn't match the numbers or the reach. From late 1943 to mid-1944, bomber losses dropped from 20% per mission to under 2. In those same months, Luftwaffe fighter losses soared. The balance had flipped not by miracle, but by math. Victory came with cost. Between 1943 and 1945, the 8th Air Force lost more than 2,500 Mustangs, and 1,300 pilots were killed. Many went down not in dogfights, but to flak and ground fire during low-level strafing runs. They'd descend to treetop level after escort duty hunting locomotives, trucks, airfields. A single rifle shot to the radiator could doom them before they reached the channel. Coolant zero, she's burning up, tell 'em I'm bailing out. They paid in aluminum and blood. But for every Mustang lost, hundreds of bomber crewmen lived. The strategic effect was catastrophic for Germany. By spring 1944, the Reich's fuel plants, railways, and factories were under constant assault. The Luftwaffe, forced to engage every day, burned its last reserves of fuel and men. By early 1945, most German pilots had less than 30 hours of flight training. The veterans were gone, replaced by boys barely out of school, facing seasoned Mustang groups with radar support and unlimited gas. At 3 p.m., after more than 5 hours in the air, the first Mustangs touched down in England. The mission had cost 5 bombers and 5 fighters, but they'd done the impossible. They'd flown to Berlin and back. From that day, the outcome of the air war was no longer in doubt. The P-51 wasn't just another airplane. It was proof that engineering, courage, and cooperation could rewrite the rules of war. They called it the Mustang. But to every crewman who watched it glide overhead and knew they might live another day, it wasn't just a fighter, it was a promise. 5 years after victory in Europe, the Mustang was called back, this time over Korea. The Air Force, now flying jets, still needed something rugged, precise, and familiar. And once again, Schmued's design answered. Renamed the F-51, it flew more than 62,000 sorties, bombing bridges, strafing convoys, and holding the line until jets could take over. For a design born in 1940, that kind of endurance bordered on the unbelievable. Schmued never stopped chasing cleaner air. His fingerprints are on the F-82, twin Mustang, 2 Mustangs joined by a single wing, and on the F-86 Sabre, whose swept wings would dominate the Korean sky. Later came the F-100 Super Sabre, America's first fighter to exceed the speed of sound in level flight. Any fool can criticize, but design it right the first time, then it flies for 40 years. In 1952, Schmued left North American for Northrop, where his obsession with simplicity and reliability birthed 2 more legends, the F-5 Freedom Fighter and the T-38 Talon. Both still fly today, more than half a century later. To engineers, those aircraft weren't glamorous. They were honest, fast enough, strong enough, easy to maintain, and built to last. The same philosophy that had shaped the Mustang now defined an entire generation of trainers and light fighters. The ripple didn't end with the military. The smooth surfaces, the drag discipline, the idea that air itself could be tamed rather than fought, those lessons migrated into the jet age. From the F-86's swept wings to the wide bodies of the 747, every airliner still carries a trace of Schmued's thinking. His colleague and friend Lee Atwood took over North American after the war, steering the company into the jet and space age. Schmued remained the artist behind the curves. Atwood, the strategist who kept the dream alive. Together, they proved that leadership and craftsmanship could coexist. By the time Edgar Schmued passed away in 1985, his impossible design had outlived most of the men who doubted it. The Mustang's shape, its philosophy, its courage, all had crossed from propellers to jets, from warplanes to airliners. He was the engineer. Nobody asked until everyone needed him. The immigrant who designed America's wings, British engine, American fuel, immigrant engineer, a partnership that reached Berlin and came back. If you love engineering that changes the math, subscribe and keep flying with us.